Schaefer and Michaela Davis.
Hi everyone, I'm Isabel.
I'm Aiden.
And I'm Michaela.
And our senior research study this year was the impact of carbohydrate gel intake on the 10K performance of recreational runners. So starting off with some background info, endurance sports such as running utilize aerobic metabolism to produce an ATP or energy. Aerobic metabolism requires oxygen to go about its ways, and then carbohydrate and fats are the main fuel sources. And according to Holly et al. And Jensen et al., when exercising at greater than 60% of your VO2 max, muscle glycogen and blood glucose are the main fuels for ATP. And then it is recommended to consume carbohydrates during exercise that lasts longer than 60 minutes. So in our review of literature, we looked at team sports, cycling, and running, and how carbohydrate use is done in those three areas. So for team sports, Nicholas et al. And Patterson et al. Found that using a 6 to 6.9% carbohydrate solution increased time to fatigue and run time to exhaustion in male collegiate soccer players, then also in hockey and rugby players. And then also consuming a 0.7 grams per kilogram of body mass and carbohydrates in a gel form increased blood glucose and performance time during a 30-minute extra time period in soccer. However, another study found that consuming a 7% carbohydrate solution did not improve performance in a simulated soccer match. Looking at cycling, where carbohydrates are used a little bit more than team sports, Kozowski et al. And Walsh et al. Found that consuming commercially available carbohydrate gels increased performance in trained cyclists and healthy males in a 15-minute time trial following a 2-hour ride or a 40-minute ride. And then also consuming 0.7 grams per kilogram of body mass was found to spare muscle glycogen uses in endurance trained males during 3-hour rides. So they were using the energy that they got from the carbohydrate instead of using their stored muscle glycogen. In running, there is some inconsistent evidence. It was found that ingesting a 6.4% carbohydrate solution during a 1-hour treadmill run, and then consuming 0.5 grams per kilogram before, and then 0.2 grams per kilogram every 20 minutes during an 80-minute run, followed by a 5K time trial, significantly improved performance in endurance trained males and also male competitive runners. But consuming 1 gram per kilogram of body mass during a half marathon did not improve performance of highly trained males in work at all. Another thing we looked at was carbohydrate loading. We've all heard of like carb loading, eating a lot of carbs before an endurance events. However, many athletes and recreational athletes struggle to fill their glycogen stores. So therefore, ingesting carbohydrates during exercise may impact sports performance, as it would provide energy directly into the bloodstream, prolonging the breakdown of muscle glycogen. So therefore, the purpose of our research was to determine the effect of a commercially available carbohydrate gel on the 10K performance of recreational runners. We chose a commercially available gel because a lot of the research we looked at quantified their carbohydrates to their participants' weights, and we wanted to do something a little bit different. We chose a 10K because there was not a lot of research done on distances shorter than a half marathon. And then we had chose recreational runners because, as you probably heard me said, a lot of the research was on male competitive runners or highly trained or endurance trained. We wanted to reach those who just participate in running for their own leisurely fun. And for our hypothesis was that consuming a commercially available carbohydrate gel before and during a 10K will increase the performance of recreational runners.
So for our study, we had to define what a recreational runner was, and here's our criteria. They had to be between the age of 18 to 65, had to have at least 6 months of running experience. We also have a couple stipulations there. That was just to make sure that we knew that the subjects would be fit enough to actually complete the 10Ks. They cannot be on a collegiate sports team. They cannot have any lower extremity injuries within the last 3 months, and then they cannot participate in carb loading during our study. We did this under the assumption that most recreationally active people do not actually truly carb load. They were allowed to eat some light carbs before the race, but not like true carb loading, as we said before. We ended up recruiting 12 subjects via a flyer with a QR code that led to a screening survey. The survey basically asks if you fit the criteria. And on the top right is just some sample questions. In the end, we finished with 9 subjects. On the bottom right is our graph with their age, VO2 max, height, and weight. We had 7 males, 2 females, 1 dropped due to injury, and 2 dropped due to time conflicts. So the design of our study was a true experimental, single-blind, randomized crossover design This basically means that the subjects did not know whether they were receiving the treatment or the placebo for the first 10K. And we randomized who received what, but then for the second 10K, we would just flip who got what. And again, they wouldn't know. So on the right is a graph, which is kind of like a schedule for our study. Pre-testing lasted about a week, and during that time we got their VO2 max, their height, their weight, and then we also had another survey asking them about their gastrointestinal history during exercise. We gave them 1 to 2 weeks of normal training period, 1 to 2 weeks kind of just when did they do their VO2 max during that pre-testing week, and then normal training was basically just keep it consistent, keep it normal, don't try super hard to try and improve between the 10Ks. We had our first 10K, which was on Sunday, gave them 2 weeks, ran our second 10K. So during pre-testing, we did a VO2 max test, which is a maximal aerobic test that measures how efficient you use and consume oxygen. For our VO2 max test, we had our subjects run on a treadmill while wearing a mask that was connected to a tube that then connected to a machine that gave us a bunch of data. So the protocol for our VO2 max test started out walking for 3 minutes, and then after that, they ran at a self-selected pace for 2 minutes, and then thereon after, every 2 minutes, the incline would increase by 2%. And the test would not end until the subject decided on their own volition to end the test, which was basically when they were too tired to keep continuing. During the test, we did measure their heart rate and RPE. So the criteria for the true VO2 max test, so basically at the end of the test, their heart rate had to be within 10 BPM of their estimated heart rate max, and then their RAR had to be greater than or equal to 1.1. RAR is respiratory exchange ratio, which is the ratio of carbon dioxide produced to oxygen consumed. So from this VO2 max, we would get a minimum pace that the subjects had to run during their 10K, which was 70% of their VO2 max. They just had to run above this.
So in terms of the treatment for the supplementation that they got, the actual carb treatment was the GU brand strawberry banana energy gel, which had 23 grams of carbs. And then the placebo was sugar-free strawberry banana jello, which had 0 grams of carbohydrates. Each of the subjects would receive a packet 15 minutes prior to starting the 10K, and then they would receive a second packet at the 5K mark. And all of our packets weighed approximately 1.1 ounces, and as you can see in the pictures, we disguised them with pink duct tape to cover the labels so that the participants didn't know which ones they were getting. And we also cut off the tops of the packets before giving them the packets so that, once again, they couldn't tell which packet they were getting. And when the participants were given the packet at the 5K mark, they had 1 lap to consume it, and then when they came around again, they were offered water to help wash the packet down. So in terms of the trials were 2 weeks apart. They were March 16th and they were March 30th. During these trials, the participants were instructed to run at race pace effort and to not fall below the pace that we determined by using 70% of their VO2 max. And we announced their split times at 1 mile, 2 mile, 3 mile, and 5K mark, but then after that we stopped announcing their times. And then on both of the time trial days, the temperature was 63 degrees, so we were not considering temperature to be a limiting factor in our study.
So the measurements that we took were blood glucose, performance time, and also a GI questionnaire. We took blood glucose via a finger prick using the Rely on blood glucose monitoring system. We took it 3 times. We took it when they arrived, which was about an hour before the 10K went off. We took it pre-10K, which was about 5 minutes before we started, and then immediately following the 10K. For performance time, we just recorded it via a stopwatch, and we provided splits up until the 5K, so the mile, 2 mile, 3 mile, and the 5K. We did not let them know their completion times until the conclusion of the study. For example, we did not want them to know if they thought they ran slow in the first one. We did not want them to try insanely hard the next one and try to run insanely fast. So we also did a GI questionnaire. They did the GI questionnaire pre-testing, which just asked about the history of any GI distress they had, and they did one following each 10K. We also asked the subjects to report their diet. So if there was if anybody had any crazy GI distress, we could look at their diet and see if they kept it consistent from time trial and the second time trial.
So in terms of our results, the main thing that we were looking at was total completion time. And we took each subject and compared them to themselves when they had the gel group or when they were in the placebo group. We did this by running a dependent t-test, and we found a p-value of 0.048, which signifies that we did have statistical significance. And we found that on average, the treatment group ran 57 seconds faster than the placebo group. And another way that we decided to compare was to compare the first half of each 10K to the second half of the 10K when they were in the placebo group or the gel group. So the graph at the bottom shows the data for all 9 of our participants, and the red bars represent the first and second half of the 10K when they were in the gel group, and the blue bars represent the first and second half of the 10K when they're in the placebo group. And for the first half of the 10K when they were in the gel group, the average 5K split was 22:49, and when they're in the placebo group, the average 5K split for the first half was 23:04. And looking at the second half of the 10K, the average 5K split was 23:30 when they were in the gel group and 24:11 when they're in the placebo group. So if you look at the gel group overall compared to the placebo group overall, both the first and second half of the 10K were faster when they were in the gel group versus when they're in the placebo group.
So for blood glucose, we ran a 2x3 repeat measures ANOVA, basically just looking at all the time points that we took to their blood glucose, and we did not find any statistical significance. However, if you do look on the graph on the right, the blue line is the treatment group, and then the red line is the placebo group. You'll notice the blue line is higher than the placebo group, meaning that they had more blood glucose in their bloodstream. This means that it's kind of in a trend in the direction that we expected, and then higher blood glucose means that the subject has greater potential during their race. And then for gastrointestinal distress, 4 participants experienced gastrointestinal distress when given the treatment, and then we found that all their diets were fairly consistent throughout. So we found a bunch of studies. These ones we found had similar results to our study. Kozlowski et al. And Nicholas et al. They did a cyclist study, and then another one did the team sports study. They contributed their significance that they found in improved performance to the higher blood glucose levels. Rollo et al. Did a running study where they also found significance with improved performance. They contributed that to the suppressed fatigue signals and stimulated reward signals for the malnutrition treatment that they did.
So some studies that showed different results than what we had were Berg et al., Piper et al., and Coletta et al. Berg et al. Did the half marathon where they consumed 1 gram per kilogram before and then at 2 points during the half marathon. They claimed that their distance was not long enough for any metabolic weaknesses to affect the performance, but they kind of carb loaded their subjects before and the day of. So their subjects being like slightly carb loaded means that they probably didn't eat the stuff they gave them, so it wouldn't have made a difference. Piper et al., they did not have a placebo group to compare their subjects to, and the runners were a little bit more experienced than our runners, so they're probably better at feeling their bodies beforehand. And then Coletta et al., they looked at different types of carbohydrates, but the different types of carbohydrates that they used varied greatly in concentration and calories, which can induce some variability in the body and kind of mask like the effects that they were looking for.
So for our limitations, the main and obvious one is that we only had 9 out of 12 of our initial participants complete the study. And we also, at the beginning, had an unequal distribution of men and women, starting with 3 women and 9 men, and then obviously we had one of those women drop and 2 of the men drop, so we really weren't able to compare the results between men and women. Another limitation is that the wind conditions slightly differed each day of the trial. There was a 4-mile-per-hour difference from the first trial to the second trial, and we were also unable to tell if the packets were completely consumed by the participants. Like, we assumed that the more that they took throughout the study, that the better they were at getting all of the gel out of the packet, but we do suspect that while they were running, their ability to get it all out of the packet was probably not the best.
So in conclusion, our study suggests that consuming commercially available carbohydrate does improve performance for the 10K performance of recreational runners. While we did not find statistical significance, blood glucose levels tended to be higher than in the carbohydrate gel.
Those are our references. Any questions?
with your participants, maintaining that 70% VO2 max pace?
No, the pace ended up being a lot slower than we thought it was going to be, so nobody had any issues staying above it.
I was just wondering, cause you said you stopped giving their times like halfway through, did they not have watches or anything?
No, they weren't on.
So they
the
just did
watches.
another time?
Correct.
So we ran on the track. Do you guys think running it on like a road course would be different results than on the track?
Yeah, I think mentally you'd be a little bit better running on the road, because running 25 laps is a lot, so on the road you have a little bit more of a mental.
I think that just the overall times, if it was on a road, would just be faster, just because you don't have the mental drag of running around and around again.
You said several of your runners experienced gastrointestinal distress. Did that seem to be correlated with whether they had the placebo or the gel?
I think 3 of them had the gel, and then 1 had like when they reported the issues.
Again, as far as your participants, was this the first time they ever used a gel in their runs, or had they been experienced using those?
Most of them
Most
had
of them
been
have.
experienced using the gels. That was one of the questions that we had actually asked them in our pre-testing, and most of the participants said that they had either used the gels or some form of carbohydrate supplement, whether it's like a chewable one or other types.
Do you think the difference is metabolic at the muscle, or is it psychological, as in the brain getting carbohydrates? Because your blood glucose was no different. And does muscle glycogen limit 10K performance? This is just your thoughts. No, this is just your opinion. You can't know the answer, so just your opinion.
I think maybe a little bit psychologically, like, oh, I took something, I feel better. But
technically, since they didn't really know which one they were taking, that's kind of why we disguised the packets to eliminate that factor, so that we hope that that wouldn't have any impact. So which is why we disguised the packets in.
Did you do RP as well?
During the races.
I'm curious if the sugar makes it feel easier, the actual sugar.